Hey everyone, and welcome back to the channel. Today, we're rediving into a topic that might sound a bit old school, but is actually one of the hottest challenges in modern tech: modernizing legacy systems. Specifically, we're talking about the epic journey of transforming COBOL code into sleek, efficient Python. So, why are we even talking about COBOL? This language, born in 1959, is the silent workhorse behind a massive chunk of the global economy. Think about it: banking, insurance, government services, airlines. A surprising number of these critical systems still run on COBOL code written decades ago. It's reliable, it's robust, but let's be honest, it's also a bit of a dinosaur. The problems with these legacy systems are piling up. First, there's a serious talent shortage. The original generation of COBOL programmers is retiring, and finding new developers who know the language is like finding a needle in a haystack. This creates a huge risk. If something breaks, who's going to fix it? Second, these old systems are incredibly rigid. In today's fast-paced world, businesses need to be agile. They need to integrate with new technologies like cloud services, mobile apps, and AI. Trying to make a 60-year-old mainframe system talk to a modern API can be a nightmare. It's slow, expensive, and often just not possible. This lack of flexibility stifles innovation and can put a company at a major competitive disadvantage. And finally, let's talk about cost. Maintaining these ancient behemoths is a money pit. The hardware is specialized and expensive, and the software licenses can be astronomical. It's like keeping a vintage car running as your daily driver call, but incredibly impractical and costly. This is where the hero of our story comes in: Python. Why Python? Well, it's pretty much the opposite of COBOL in all the right ways. It's modern, incredibly versatile, and has a massive active community. The syntax is clean and easy to read, which makes maintenance a breeze. Developers love it, which means the talent pool is vast and growing. Python's real superpower is its ecosystem. It has an incredible library for everything you can imagine, from web development with Django and Flask, to data science with Pandas and NumPy, to machine learning with TensorFlow and PyTorch. This means that once you've moved your core logic to Python, you unlock a universe of modern capabilities that were completely out of reach with COBOL. So the big question is, how do you actually do it? How do you take decades of complex, business-critical COBOL code and safely migrate it to Python? This isn't just a simple find and replace job. It's more like performing open-heart surgery on your company's IT infrastructure. The first step, and this is absolutely crucial, is analysis and planning. You can't just jump in and start rewriting code. You need a deep understanding of what the existing COBOL application actually does. This involves poring over old documentation. You're lucky enough to have any and talking to the few remaining subject matter experts. Automated analysis tools are a lifesaver here. They can scan the COBOL source code and help you map out its structure, identify dead or redundant code, and understand the complex web of dependencies. This process creates a business rule catalog, essentially a blueprint of the system's logic, independent of the original language. You need to know what the system is supposed to do before you can even think about how to rebuild it. Once you have that blueprint, you have to decide on your migration strategy. There isn't a one-size-fits-all approach. One popular method is the strangler fig pattern. Imagine a fig vine growing on an old tree, slowly wrapping around it until it eventually replaces the tree entirely. In software terms, you build new Python services around the edges of your old COBOL system. For example, you might start by building a new Python-based API that accesses the old COBOL database. New features are built in Python, and gradually, piece by piece, you rewrite and replace the old COBOL modules. Over time, the new Python system grows and the old COBOL system shrinks until one day you can finally turn off the mainframe for good. This is a great low-risk approach because you're migrating incrementally, testing as you go without a scary big bang cutover. Another approach is automated refactoring or transpilation. This involves using sophisticated tools that can automatically convert COBOL code into Python code. Now, this sounds like magic, but it's not perfect. The resulting Python code often isn't very Pythonic. It might work, but it can be clunky, hard to read, and difficult to maintain. It often looks like COBOL written with Python syntax. These tools are best used as a starting point. They can do the heavy lifting of the initial translation, but you'll almost always need human developers to go through, clean up, and refactor the generated code to make it truly maintainable and efficient. Think of it as a rough first draft that needs a good editor. Regardless of the strategy, testing is paramount. You need a rock-solid testing strategy to ensure the new Python system produces the exact same results as the old COBOL system. This means creating a comprehensive suite of tests before you even start the migration. You run these tests on the COBOL system to capture the baseline behavior. Then, as you build the Python version, you run the same tests against it. The goal is to get a perfect match. Any discrepancy means you've introduced a bug. Let's walk through a hypothetical example. Imagine a large insurance company. Their core policy management system was written in COBOL in the 1980s. It handles everything from calculating premiums to processing claims. It's reliable, but they can't create a mobile app for customers to file claims, and integrating with new partners is a year-long project. Using the strangler fig approach, they could start by building a Python microservice that handles one small piece of the puzzle. Premium calculation for a new simple insurance product. This new service reads from the same mainframe database, but runs in the cloud. It's a small, manageable project. Once that's successful, they build another Python service for address changes. Then another for claim status lookups, exposed via a secure API to a new customer portal. Each new piece is a modern Python application. Over several years, they systematically carve out functionality from the old COBOL monolith and rebuild it in Python. Eventually, the mainframe is just a database, and the final step is to migrate that data to a modern cloud database. The legacy system has been successfully strangled. The benefits of this transformation are massive. The insurance company can now innovate rapidly. They can launch a new mobile app in months, not years. They can use Python-S data science libraries to analyze risk and personalize premiums in ways they never could before. Their developers are happier and more productive working with modern tools, and over the long term, they save a fortune on mainframe maintenance costs. But let's be realistic, this journey is not without its challenges. The biggest one is often cultural. You need buy-in from everyone, from the executives who approve the budget to the IT team that has been keeping the old system running for decades. It's a significant investment in time and money, and the benefits aren't always immediate. Data migration is another huge hurdle. Moving decades of data from a complex mainframe format like EBSTIC to a modern database format like UTF-8 without corrupting anything is a highly technical and risky task. It requires meticulous planning and validation. But despite the challenges, modernizing from COBOL to Python is not just a good idea for many organizations. It's a matter of survival. Sticking with legacy technology in a digital-first world is like trying to win a Formula One race in a horse and buggy. It's just not sustainable. So, if you're a developer, learning about this space can be a huge career booster. Companies are desperate for people who understand both the old world and the new people who can bridge that gap. And if you're a business leader, start asking the hard questions about your legacy systems. What's your modernization strategy? Because the risk of doing nothing is often far greater than the risk of moving forward. This has been a deep dive into the world of COBOL to Python modernization. It's a complex but fascinating field that's reshaping the backbone of our digital world. I hope you found it interesting. If you have any experience with legacy modernization, I'd love to hear your stories in the comments below. Thanks so much for watching. If you enjoyed this video, please hit that like button and subscribe for more content on all things tech. See you in the next one.